Hello again, mortals. We are here once again to talk about nightmares and ghosts. And today we're going to hear from Jacob. And I was reading his bio, and the bio was chaos, chaos, chaos. And I was reading the talk description, and the talk description was also chaos. So I'm going to leave this with Jacob to explain all of his chaotic adventures. Jacob, to the floor. Wait, to the floor? Is that an expression? Well, to the stage.
It works both ways, I think. Yes, thank you so much. So first off, I have to admit something to all of you. I loved being on call. The fact that a company, much less a multi-billion-dollar company, would rely on me to save the day when needed felt incredible. Is this how it feels to be Spider-Man? I always wondered. Just in this case, in the context of getting woken up at 4 a.m. to save the day. Hundreds of incidents resolved by little old me. So here's a good one. At the time, I was a cloud operations engineer in charge of the infrastructure for our analytics reporting platform. It was mostly on Windows and connected to our domain. This is important to remember in a sec. So when I onboarded, we would actually spin these up via some Amazon Machine Images. The platform lived in AWS, throw them on our domain, give our devs access to it, and they were off to the races. So one of the key reports here was something called an hourly flash report, which was the report that told us how much we were forecasted to make and how much we did end up making. So incredibly important as an example. At this point, we'd actually had the conversation about replacing this with some automation, but it kept getting kicked down the priority list. That is until this particular day. Of course, the day before my vacation started, right before the long Labor Day weekend. So typically what would happen is our developers would go in, do a bunch of changes, and typically stop their instance. But this was only on the Linux side of things. On the Windows side of things, this didn't work that way because of the fact that they were manually added to the domain and then their software was manually installed, which again, as you can tell, is probably why it needed to be automated. But the problem is that they stopped these Windows instances, which actually turned out to be in these really old CloudFormation templates that actually had autoscaling enabled. So you could probably guess what happened. The instance stopped, and by stopping, it terminated and replaced itself with a brand new one. A brand new one with absolutely nothing on it. Not on the domain, no software, absolutely nothing. So as you can probably imagine, the fire alarms, so to speak, went off and we were off to the races. So instead of having a very chill day, which I expected to then go in and actually start my vacation, I actually spent the entire day rebuilding it from 0 to 100. So yeah, not an awesome day. So we learned a lot about ourselves and about our systems from failure. In a lot of cases, we feel like we're this meme, just hanging out and feeling like we're this dog saying this is fine as the fire surrounds us. But it doesn't have to be that way. So good afternoon or good evening or even good morning, wherever you are in the world. My name is Jacob Plicque. I'm a senior solutions architect at Gremlin. I'm also a very serious wizard where I help our customers across a variety of industries, including finance, e-commerce, airlines, retail, insurance, you name it, build out their chaos engineering practice. So in case you didn't know, Gremlin is a hosted SaaS platform that lets you run chaos experiments simply, safely, and securely. I've actually been at Gremlin for just over 2 years now and previously worked at a large sports e-commerce company called Fanatics, where that story originated. So as both a cloud operations and senior site reliability engineer there for a little over 4.5 years, I was responsible for providing a reliable e-commerce experience to process over 1,100 orders a minute while training junior SREs. So as you can imagine, reliability has been the bread and butter for quite a long time, especially during peak days such as Cyber Monday and Black Friday. So how did we get into this crazy world that we're in right now? So if we start right now, this recent move to working from home and shopping purely online has put a lot of strain on different companies across every single industry because frankly, many of them were not prepared for this level of demand moving to curbside instead of having folks come into the grocery store, for example. But if we actually zoom out a bit, this has actually been a problem that we've had for years as we keep building on this crazy rapid innovation in our digital world. So we see things on Twitter of companies running into issues, sharing the hashtag HugOps. And we often see regular e-commerce failures on Black Friday, breakdowns at banks and financial institutions, and in the worst case, life-threatening incidents on airlines. So there's this cost of major technological breakdowns goes far beyond just the billions lost in company revenue. So actually, speaking of Black Friday, Cyber Monday, I remember specifically the day that everything changed about my on-call life. So Cyber Monday was year over year the best day in company history, miles upon miles on top of it. And we would often scale up our instances in advance, pre-warm our load balancers, go through this long launch readiness checklist. We've been preparing for this one day for 6 months. We were excited, we were ready to go. Then we started seeing a bunch of NX domain errors, which we then started looking at our DNS cluster. That looked fine. And I remember specifically like feeling that the walls were beginning to close in because I, of course, was the incident commander for Cyber Monday this year. And now I have no idea what to do. I know I need to escalate this. I have no idea what's going on, what's wrong. And every minute is thousands of dollars down the drain. Of course, this is also the same week as AWS reInvent. So people are popping into our call in from Las Vegas, the Venetian in the background. Eventually, we looked at our service discovery cluster and saw a bunch of our EBS volumes couldn't handle the IO load. We actually then realized that our EBS volumes that we load tested were of a different size than they were in our staging environment. So completely invalidating it completely. But we only found this out from a postmortem several days later. So moving on, more transactions and business is performed online than ever. So we see our network speeds are constantly increasing, which of course means that users are getting much more demanding. So we're looking for ways to satisfy this demand quickly and cost effectively. So this may mean breaking up your monolithic systems for performance reasons, making distributed systems for ease of management and the promise of reduced infrastructure costs. And of course, the need for tracking all of these services wherever they are. But frankly, with more complexity comes more risks that things will break. So in order to keep up with the speed of innovation, we've adopted new technologies and approaches. So your team or your company's journey is likely somewhere on this slide. But this added complexity, in a lot of cases, comes at a cost. So we're increasing the rate that we change, which increases the complexity of our systems, which increases the number of failures that we have, unless we're investing in both velocity and reliability at the same time. So this is what allows us to shift this curve to achieve both reliability and speed. However, as this journey continues, we start to think of the definition of operational maturity. So the majority of our industry considers being operationally mature as being ready to fight incidents. Now, this is a major component in the maturity of a company, but I'd argue it's actually only half of the picture. So I like to think about operational maturity as actually having the ability to be proactive. So you can interpret this as having the ability to architect for failure in your development environments, and then testing your assumptions about your systems early and often. But of course, we have dependencies on networks that we don't own, infrastructure that we don't control, open source or legacy dependencies that we're relying on, and frankly, people operating systems that can be unreliable. We're starting to understand that testing just the code of our application isn't enough. So we need a new way to test the other parts of our application stack to be sure that we've configured everything correctly and that all of the processes are in place. So this is just a small piece of the proverbial iceberg. And to make matters even more fun, we are responsible for the reliability of systems that we just don't understand. So how do we efficiently test and operate these complex distributed systems that we've built? So that's where chaos engineering was born. So if you remember nothing else, just remember these 4 words: thoughtful and controlled. The term chaos is more of a misnomer, or thoughtful and planned even. So it's more about validating or disproving a hypothesis that you have, and also revealing weakness. The ultimate goal of chaos engineering is to shine a light on latent issues that already exist. So if you think back and you've had to walk into an attic or a basement, and maybe you've seen a few spiders around. If you turn off the flashlight, it doesn't mean that the spiders aren't there, right? So you want to think about it that way. Now, what some people don't know as chaos engineering is getting more popular is this has actually been a practice we've been doing for a long time. So about 15 years ago or so, a gentleman by the name of Jesse Robbins was working at Amazon, manually wreaking havoc in data centers. He was known for going into an Amazon data center and unplugging a power or data cable and picking up his phone and seeing who got paged. Pretty wild start. He actually became known as this master of disaster and actually coined the term game day that we use today. So in 2010, many large enterprises are proactively doing disaster recovery testing behind closed doors. It's starting to become, at this point, their secret sauce. That's also when Netflix created Chaos Monkey to facilitate their move from physical infrastructure to the cloud. Then the following year, Netflix announced the Simeon Army toolset, adding a few additional failure modes, allowing for some more complete suite of failure testing. Then in 2014, Bruce Wong coined the term chaos engineer while working at Netflix. And that's when the industry started to join Netflix in practicing chaos engineering as a means of increasing resiliency in complex systems. And then in 2016, Gremlin was founded by Colton Andrus and Matthew Fornicari, our CEO and CTO, to help democratize this practice and help companies harden and prepare their services for internet scale. So there's also this concept called the blast radius. So when we start to think about building out experiments, we should start small and carefully and purposely increase our blast radius. So this typically means experimenting with a single or a few hosts at first, not your entire fleet. This can also mean starting in your development environment and expanding outward. So there's actually a cycle that is utilized when you expand your blast radius that actually starts over as you escalate up your environments. So we mentioned a little earlier about architecting for failure. So if you adopt the practice in your development phase, that gives your engineers the ability to do this there. Then once you're confident with a particular failure mode, begin testing that in your staging environments on a subset of hosts and then expand. And then rinse and repeat on your way to your production environments. So chaos engineering brings two really, really crucial benefits. So first, we can proactively identify and fix bugs that could produce an outage rather than waiting for system failure to show us where the weakness is. And secondly, by running proactive game days, our engineers grow more familiar with system behavior, which actually makes them more effective during an incident. Not to mention, this also helps us tune our monitoring and detection systems so we can detect issues earlier. Now, I think in my younger grade school years, I for sure took fire drills for granted. But now we can train for incidents by doing them. So we do these fire drills to train ourselves to stay calm and know exactly what to do when things go wrong. So if you think back, have you ever been previously given an on-call phone or pager and been told, good luck? I sure have. That analytics platform situation is a good example of that. So in many cases, I didn't have a run book or an architecture diagram on a system that I was primarily responsible for the reliability and incident management on. So we can make on-call less painful by running these scenarios as part of either onboarding a new engineer, as well as ongoing training exercises. But even when runbooks and solutions like this do exist, fire drills are a great way to make sure that they simply make sense. So I once ran through an exercise with a customer and everything was going perfectly. Alerts triggered the right people. They responded promptly, no issues logging in and getting into things to get things fixed. But then we actually got to the runbook that we needed to actually fix the problem. And the runbook said, wait 15 minutes. Not exactly actionable. So where can we get started? We've already talked a little bit about fire drills and touched a little bit about monitoring gaps, but as we continue to advance from a technology piece, migrating to microservices, maybe you're moving to the cloud or thinking about adopting Kubernetes, there are a multitude of different ways to get started. So if we zoom in a bit, there's a lot of really cool places to start from a monitoring perspective. A couple of my favorites on this list are slow response from your database. It seems to catch a lot of folks. I've run incidents where that was the result of the problem. or the problem, I should say, just in general, or if a dependency of yours is unavailable, how does my application handle that? Or if we zoom out, sort of the chaos engineering 101 is CPU utilization. High CPU utilization shouldn't cause my application to run into problems, and I have the ability to scale horizontally. Now we can prove it. And then from an incident response piece, that's kind of the next level from there. My absolute favorite use case is to take an incident and reproduce it, validate that we've gotten better based off of how we've instrumented both playbooks or some monitoring around that particular incident. So a really great example of this is I was actually talking to one of our cloud architects and when I was still at Fanatics. And we actually had this long list of these failure scenarios. And it's a wonder I started to work on chaos engineering much later, because I remember being very excited. These scenarios made sense. When are we going to go test them? And then the can kept getting kicked down the road again. And I remember specifically asking about our direct connect, because we had a hybrid cloud architecture. We had our fulfillment centers on-prem, and most of the front end and everything else was in the cloud. So if our direct connect is unavailable or goes down, what happens? And no one knew the answer. So pretty scary, but we can go test it. And then we talked a little bit about the cloud already, but let's also ensure that our autoscaling is tuned, our team's prepared for degraded or lost networks, and that region evacuation, or even before that, availability zone evacuation, doesn't knock you offline. And the cool thing is, whether you're in AWS, Azure, or GCP, all of them have design principles used internally for their own systems that they actually publish for other companies to leverage. So these design principles include practices such as running game days to test your workloads and train your teams and simulate failure in an automated fashion. So just imagine if this was our norm. And the reality is that we're on our way. It's starting to happen right now. So there's no need to wait until something bad happens and then postmortem. Let's actually stop reading outage postmortems and start sharing our pain points with each other. I actually ran a happy hour at our Chaos Conf a few weeks ago, where we all hopped on a Zoom, about 30 folks. It was actually called Fail Whales of all things, and to talk about failure stories. And no one felt comfortable talking except for me, which super resonated with me, that we have to open up a bit, because in a lot of cases, we're trying to solve a lot of the same problems. So these stories and doing chaos engineering will help our situations not suck. And so we have to get better at telling these stories, even the things where we felt like we went wrong. So for example, practice what you preach. So when actually putting together a patching program for our DNS servers, I once accidentally in my script brought down both of the DNS servers at the same time for our Merge Center application during a USC event, during the main event, right when we needed to push product. Not awesome. But as you can probably imagine, that script was fixed and we actually automated that process later. Another similar situation, my very first production deployment as a cloud engineer, fansedge.com is like the 4th most popular site in the Fanatics suite of sites. And I actually brought it down by adding a preceding space actor or load balancer during a blue-green deployment. So that was a fun 30 seconds of panic as I saw the white screen come up where the website should be. But that was quickly fixed, and we realized that the actual process itself shouldn't rely on someone plugging in or copying and pasting a load balancer that then caused that incident. So we were able to fix that too. And then, hey, the S3 outage is a really popular one to talk about from 2017. And everyone talks about, oh man, like Amazon, should have seen that coming. It was a human error, things like that, as I almost kill my mic. But the reality is, and I remember this conversation too, we actually talked about going multi-region literally 5 days before that incident. And we decided not to due to cost. Everything in our situation was in US East 1 at the time. So we ended up just like everybody else, almost half of the internet, felt like it went down. We waited for our cache to die via Akamai. We had about an hour, and then all we saw was lots of red X's, and then poof, we were gone. And then, of course, the S3 outage page also relied on S3 as a dependency, which ended up pointing us in the wrong direction. But all in all these stories, as fun as they are to tell, they taught me a lot. And it became a very big lesson for me. So let's be proactive and run through these types of scenarios ahead of time. All these stories are what directly led me to finding out about chaos engineering and where we're going as an industry, and essentially why I'm here talking to all of you today. So we're all here to learn and get better and have a good time. So chaos engineering creates this really, really interesting force function that causes us to ask questions about our systems, and just as, if not more important, about and to our people. It's actually really incredible to see teams asking questions they've never asked before, and frankly, being able to answer them. So what if you're on call this sprint? Maybe run some experiments in your lower environments, have a bit of a chaos hour during your sprint. Obviously, over-communicate and have this conversation with your team. The worst case scenario is you validated an assumption you had about a system that you're responsible for, and you learned something. Best case, you might find some surprises that if they happen upstream in production, they would have caused an incident. So a few things before you go, just a couple links. So just as a small thank you for hanging out and listening, if you go to gremlin.com/talk/Duval, we actually have a bunch of really cool Gremlin stickers, so you can check that out. And also we have about a 7,000 person, I think last I checked, Slack community, as well as some tutorials and things in which to kickstart your chaos engineering practice at gremlin.com/community. And quick note on a blog that my really good friend and cohort Vince wrote about not being an on-call hero. It was actually one of the reasons why I created this talk. So check that out. And lastly, speaking of Vince, we actually just wrapped a 2-part series on planning and architecting for reliability, and show some demos and what we've learned. So feel free to check that out as well. So thank you for listening again. I hope it was helpful. Tweet at me, add me on LinkedIn, email me, Slack me. I think we have maybe a few moments for some Q&A. So always happy to chat. And lastly, as one of the best teachers in the universe, Miss Frizzle said of the Magic School Bus, take chances, make mistakes, get messy, just not in prod just yet. Thanks.
Thanks so much for your talk, Jacob. This is certainly a very interesting subject, and I think it's nice that in this Halloween theme we had, you're not the only speaker today who came here to talk about the times when things went wrong. And I find it really cool that people, I think sometimes people are embarrassed to admit things that went wrong, but I really like it when people just share this kind of information openly. I don't see any questions on the chat right now. We do have a few minutes, so maybe let's wait a minute or two and see if anyone has a question.
Sure.
Meanwhile, I'd like to say thanks to Container Solutions for organizing this conference, and big thanks to our sponsors. They are Container Solutions, Equinix, Cycloid, Giant Swarm, Instana, and Keyvoke. We also have, well, I think most of the events we already done during the day. I know we had like a pumpkin carving competition. There was a cocktail masterclass. I'm really curious to see who wins that because that's a contest too.
For sure.
So yeah, I don't see any questions in chat. If you have questions for Jacob, you can reach him on the whole or on the conference Slack as well. Awesome. Do you have any last thoughts, Jacob?
Yeah, just one last one. Just again, thank you all so much. It was a pleasure to put this together, and it's a hell of an event.
Thanks a bunch. So we're going to take a small break now and see everyone in a few minutes, where we're going to talk about some kind of a massacre. We'll see what that's about.
Oh boy.